Virtual lab for Rotary dryer developed by a group of IIT Guwahati faculties and students from the Department of Chemical Engineering. The first step is to log on to vlab.co.in. The second step is to click the link for virtual lab at IIT Guwahati. Step is to click the link for virtual lab for mass transfer. The fourth step is to click the link for Rotary dryer, which takes us directly to the online portal. On the online portal, the first tab is the theory tab, which gives us the aim of the experiment, a general introduction behind the experiment, the description of the setup, and finally figures for the experimental setup. The second tab is the procedure tab, which gives us a basic theory and the experimental procedure in steps, along with assumptions which we have assumed while carrying out the experiment. Lastly, it also shows the animation of the experimental setup. In the animation, it could clearly be seen that the wet solid is fed into a rotary dryer and hot air is blown from the opposite side, and dry solids has been collected on the other end. Next, we have the experimental calculation tab, in which one set of detailed explanation of experimental set has been shown, along with an experimental figure for the same. Further, the flow sheet has been shown for the calculations, where the input is the pressure, based on which values for H, the flow rate, LMTD, and finally G, that is a mass flow rate, and the air mass velocity, along with overall heat transfer coefficients, has been evaluated. At the end of the experiment, we plot a graph of between ln of overall heat transfer coefficient and the air mass velocity. The output in this case are four temperatures T1, T2, T3 and T4. Then we have the lab calculation tab, which consists of snapshots of the virtual experiment. The first step is in which the pressure is the input and the temperature are the outputs, which are virtually calculated from the code. The next step is the calculation part, in which the input is the pressure and the user has to enter data for volumetric flow rate, mass flow rate and air mass velocity. In the third step, we have to calculate the overall heat transfer coefficient based on the virtual data obtained from step 1, that is T1, T2, T3 and T4. In the step 4, the user's data has been compared with the virtual data as to see how much of error the user has made while performing the experiment. The step 5 is the concluding step, which gives the user basic knowledge as to where he was wrong while carrying out the experiment, along with the marks obtained depending on his performance during the experiment. The next tab is the pre-experimental quiz tab, where the user has to answer the multiple choice questions and press the submit button. The software will enable the user as to how many questions of his or her were correct and how many were wrong. The next tab is the video tab. In the video tab, there are two videos, one for the virtual world experiment and the other for the real world experiment. These videos will help the user to have a depth knowledge of the experiment he is carrying out. Further, it would also give the user a feel as to his doing the experiment online. The next tab is the downloads tab, where the user has to just download the runtime engine depending on the operating system and run the simulator. In the simulator tab, there are two links, one to perform the experiment online and other to download the exe and perform the experiment offline. The next tab is the post-experimental quiz tab, which is similar to the pre-experimental quiz tab. All the user has to do is select his answer and press the submit button. The next is the help tab, which gives the user general instructions how to use the simulator. Next comes the feedback tab. This tab enables the user to let the developer know about his or her experience as to what is good and what is bad in the experiment, as to what difficulties he or she has faced while performing the experiment. All the user has to do is answer the questions and press the submit button at the end of the page. User has to go back to the simulator tab, download the exe file and run it. Here comes a real world experiment.
This is the experimental setup showing the YouTube manometer. This is a section of the setup which shows the switches for motor, heater and blower. This is the valve for flow rate. This is the blower. Now we on the system. First we on the motor and then the heaters and then the blower and set the temperature to 50 degree. This is the silica gel pellets which we use as input. We add 20 ml of water to 100 grams of silica gel. And put it into the feed hofer. We allow the wet solid to flow through the dryer by starting the screw conveyor at the prefixed speed. These are the 4 thermocouples. Now for this we have temperatures. Like for third thermocouple the temperature is 33.7, for the fourth thermocouple the temperature is 33.6 and so on. This is a section of the setup where we get the dried silica pellets. After drying, the color of the pellets changes to white as can be seen. Now we off the setup once we get all the dried silica pellets.
Now next we have the virtual experiment.